I wanted to welcome you to Strand Map. It's a speaker series that the Design Lab runs. The speakers, as you'll see over the quarter, sort of widely range over a lot of topics, and all of them intersect with design. If you're taking this for credit, be sure you sign the sign-up sheet that's going around. It's a special honor to introduce our two speakers today. Clemens and Peter, both are professors at Aarhus University in Denmark. And they collaborate together on a number of projects, and they're going to collaborate on the talk today. They're co-directors of a new Center for Digital Creativity at Aarhus. Both have received, I think, all of your degrees from Aarhus. Clemens is a computer scientist, and he has an even longer association with Aarhus University because he was born in a hospital on the campus many years ago. And his father was a physics professor at Aarhus. His wife is a physicist. And Clemens leads a really novel project that I think he'll show you some examples today of trying to make the web and software more collaborative and easier to run across multiple devices. And it has a really elegant way of doing it by making the DOM persistent. And I highly recommend taking a look at it. You'll be enticed today, but the system is called Webstrates. And I suspect we're going to see some demos if the three computers and the phone connecting two of them continue to work. And Peter is an interaction designer and sort of focuses on enhanced tools and spaces to help people be more creative and to innovate. He's a full professor in interaction design, and they're always trying to include a few lesser known things. You can find out all of these things by looking at their web pages. Peter was a karate champion during his high school years, so be careful. I'm told he's known for his speed and sprinting to catch flights, that he leaves younger and older faculty in the dust behind him. Clemens is into arcade games. He actually has a couple of old arcade machines in his basement. He also occasionally plays World of Warcraft, I'm told. And recently he and his wife have reached the max level. Peter isn't a gamer, I'm told, but I hear there's one game, a famous soccer game, that he's quite addicted to. Today we're going to see a brief view of their work, and there's a lot of really good work, and we're only going to get a glimpse of it. But I think we've been looking at this kind of thing. If we sort of have this paradigm of building applications, and those applications are often walled gardens that are trying to keep us inside of them. And so, they're going to talk a little bit about first documenting creative work and looking at creative work, and then how, what it would be, how can software be different, that Clemens is going to talk about. So, here they are. Great. That was a perfect out of swing for me.
Thank you so much. I think I can speak for both Clemens and myself to say that we're very thankful for this invitation to be here. We work at the same research center, so I'll be doing some general introductions just to give you a brief overview of what we do. And without giving away too much, I can also say that towards the end of my talk, I'll be moving towards discussing some of our most recent projects and collaborations. And they build on some of the technological components and the technological infrastructure that Clemens will then introduce you to. So if it's a bit vague towards the end of my talk, don't worry about it. He'll clear it all up when it's his turn. When I was invited to give this talk, I thought I'd use it as an opportunity to look across a range of the projects that we've done over the years, and to try to identify some overarching theme that might also resonate with you. And across our labs in Aarhus and here at the Design Lab at UCSD, I know that one of the things we share an interest in is exploring the role and nature of digital systems in creative work, so I took that as my starting point. And moreover, as researchers, we typically also share an interest in capturing empirical data about these creative processes so that we get some kind of observable externalizations that we can analyze. So this led me to consider how we've gone about documenting creative work through a range of projects that I've chosen to go back 10 years and then offer you some examples of this work. I'll also be pointing towards some of the things that we will be doing in the future. So I'll firstly talk about where we started out, namely as researchers trying to document and capture what goes on in different types of creative work, mainly in design practice. I'll offer you 3 cases in which we've done this, and then I'll move on towards something that we realize that we really probably ought to support in a much better way, namely in helping creatives document their own work. And I'll also offer you 3 cases from that, and then I'll point to a few things that we'll be doing next. I have some references and so on. They're all on the last slide, but I think what I'll do is, at the end of this talk, I'll tweet you all the takeaway messages and all the references so that you can look at them at a later point in time. As for a very brief introduction, Clemens and I are both at Aarhus University. We are formally at the Faculty of Arts, but I think that's because it's very hard to figure out where to place human-computer interaction. On our side, we're more on, at least formally speaking, on the human side of the divide. We're co-directors of the Center for Digital Creativity, and we're also part of the larger human-computer interaction research group at Aarhus that comprises about 40 researchers or so, I think. The Center for Digital Creativity is kind of a frame for 6-7 projects that we do. There are 20 researchers of us in the center, and we have a number of collaboration with external partners, architects, software companies, municipal services, and so on. And very, very briefly put, the thing that we're exploring is this move from supporting and automating primarily routine office work towards using IT and creative knowledge work of various sorts. So we're interested in figuring out how digital tools influence creative work and how they might help us explore things and create in new ways. So looking firstly at when researchers document creative work. If any of you have tried studying creative processes such as design, you will know that there are a ton of things going on that could potentially be of interest. If you carry out experimental design research and you look at how people go about doing creative work, you'll see that it's a messy affair, and I say here that it's comprised of multiple levels of wicked problems. The notion of wicked problems is a way of describing what goes on in many design situations as being unique situations where you can never replicate the same situation. So in and of itself, design is often something that addresses a wicked problem. Then when you try to carry out research into design, you're introduced with another level of wicked problems, namely that you can only set up a study in one way to capture this very unique situation. You can't go back and then do the study over again as long as you're observing what people do in realistic settings. And that is actually very often what we do. We try to go out and see what actually happens in creative practice. We also do experimental setups once in a while, but a lot of our work is focused on understanding how creative professionals work in practice. So as researchers, we're interested in figuring out how we can capture what goes on in design and how we can use this data to inform and generate design research insights. And I'll give you a few examples of this and then point at some of the issues and implications that emerge when we try to do this. So the first example I'll give you is from a case that is about 10 years old. It's based on a publication called Maps for Design Reflection. And in this case, we collaborated with an architectural studio of an architect you might have heard of. His name is Bjarke. He's since done a lot of international projects. We were fortunate to work with him when he still had time to collaborate with researchers such as ourselves on a case that was an architectural competition to develop a new museum of modern art. And in this project, we collaborated and we were invited into the project because we had done a number of projects in the field of media architecture. Media architecture is the practice of integrating digital components and interactive components into architecture and into the built environment. And we scaffolded a range of ideation workshops and presented a number of opportunities for doing this. And one of the technologies that we introduced was something called thermochromatic ink, which is basically ink that, concrete, thermochromatic concrete, which is basically concrete that can change its color and become transparent as you heat it up or cool it down. And this means that if you imagine two layers of concrete, one of a solid color behind it, and then thermochromatic concrete in front of it, then by controlling the heat of one layer of concrete, you can use it as a kind of organic display. It takes time, of course, to heat it up and so on, so you could say that the refresh rate is very slow on this type of concrete, but it gives you some unique properties when you integrate it into large-scale architecture. And the architects were very fascinated with that, and they wanted to integrate it into this proposal. We developed a number of different ideas for doing that, and then set forth about, integrated it into the final proposal for the building. And I won't really talk much about the final building, but what I will talk about are three ways in which we tried to capture what went on in this process. So we were interested in this project in figuring out, when we ended up with a particular idea, a particular design proposal at the end, then trying to figure out if we could trace that final concept back to its origins. So we were interested, in other words, in figuring out when did these ideas that led to the final product, when did they emerge, how did they evolve, synthesize, diverge, and so on over the course of a project. Or in other words, I mean, why did we end up with that thing and where did it come from? And in order to be able to study that, we then developed three types of maps to capture and to get a sense of this flow, namely what we call an overview map, a strand map, and a focus map. The overview map is basically a map that tries to capture the totality of this design process, where we were trying to map out the different ideas that came into play, the sources of inspiration they drew upon, and the particular types of conditions, or you could say the affordances and the constraints in the situation that were crucial to in determining whether or not we could actually bring an idea to fruition. And we also looked at different forms of media, whether something was basically spoken words, if it was put into text, images, movies or clips, or if it was actual physical models. So basically a way of trying to map out all of these ways in which the final idea might manifest itself, and then trace the development of these over the course of time. On this basis, we developed a second type of map, what we call a strand map, and you're actually, I couldn't fit this meaningfully into this slide, but this is actually one long strand of ideas where we then went all the way back to the first point in time at which we could identify what then became the final idea, and then tried to look at all the different ways in which this idea became manifested and changed and so on over the course of time. So this strand map corresponds to different things that we could identify in the overview map. So, and then finally, what also became apparent was that many of these different types of manifestations were the result of very particular design events and activities. So what we have here is basically the way that an idea or a concept is manifested, but we didn't really know much about how and why it came to be manifested in that way. I'll move over here so I can reach it. So we developed a third way to try to capture it. Now we call it maps. This looks more like a table. And basically, focus maps are maps that then try to, for each of these events, describe what it was that we did, why it was relevant to do it at this point in time, which approach we took to doing it, why we took that approach, what came out of it, and which types of insights this brought us in terms of the ongoing project. And for these, we developed a large number of focus maps to try to look at each individual situation. So in many cases, you would actually end up with a design session being comprised, for instance, of a series of rapid fire experiments to try out different variations on the same theme, and then put them all together. So in another sense, what we've done with these maps is basically to try to move from the very overview of the totality of the project, and then to zoom in on the different manifestations, and then to look at each of these situations and try to analyze how we came to manifest an idea in a certain way in that process. This was the very first example, and some of the findings, I would just say that what we figured out early on was creating these overview maps. That is an extremely time-consuming thing to do, and I still don't know if it was worth the effort. It was worth the effort in the sense that we could write a paper about it, but I'm not sure it's worth the effort in terms of doing it all over again. They give this sense of general trends, and it might actually be necessary in order to also do the strand maps and the focal maps and so on. But really, what seems to work well is the ability to move between these different types of maps. What we also realized is that actually, being design researchers, you often need to be present in the room if you want to capture what is going on. You need to become participant observers. There are many of these things that we could not have captured if we had not been involved in the process ourselves. We also realized that this quite simple schematic way of working with the focal maps actually was lightweight enough to carry out in quite a rapid way, and that led us to develop another way of trying to capture or map the process, which we call design space schemas. We've been using them across a range of projects, and it's based on a very simple idea. Basically, you try to map out the parameters of the design space and figure out which options you have. So we call these aspects and options. So for instance, in the case of the art museum, we identified some of the main ways in which we might use this thermochromatic concrete. For instance, the materials that we might employ in order to heat up or cool down these things, water, electricity, air, and so on, the form that it could take, the way that these forms, for instance, dots could be combined into matrices or lines, where in the museum space it could be placed, which situations it could support, how the interaction could unfold, what we could represent, and what that type of content could be. So basically, this is a very, very simple way of trying to map the design space, the different parameters that designers can somehow manipulate in order to get towards a final solution. And once you have that, then you can start experimenting with different ways in which you can then create design concepts. So each design concept can be represented as a selection of these different options within the overarching design space. For instance, here, figuring out ways in which you might use the thermochromatic concrete to represent visuals of artwork, or in a different rendering, showing, for instance, how many people are visiting the museum at a given time, or how many people are in certain parts of the museum so you can go where it's less crowded and so on. We've employed this across a range of projects. I'll just show you one other project, a collaboration with another architectural firm to develop a media architecture facade for a large building at the city square in Copenhagen, the capital of Denmark, which actually employed the same type of system. But what they found very useful, the architects in this case, was that in addition to helping their own process in terms of understanding the design space and how different potential solutions were strands, if you will, through this design space, they also found it useful as a way to communicate to outside parties what the different design concepts were and how they could be combined in different ways. So here are a few of them. And Just to give you an example, this represents one of these design solutions. It's sped up. One of these ways of using this interactive architecture or media architecture facade that they ended up building was during a culture night in Copenhagen, where they basically invited everybody to play around with and to paint on the facade of this building. So, these design space schemas are very easy to understand. They're also lightweight and easy to use both for designers and external partners. And we found in a number of cases that they're actually quite good at supporting concept development and communication. Of course, there are also some downsides. They're very simplistic, and once you start diving into it, you see that each option can actually be manifested in different ways. And it can also seriously limit or constrain your understanding of the design space if you log on to a few parameters early on. So this was the second way of trying to document the creative process. Following that, we developed an online tool, the Process Reflection Tool, which is a collaborative online system for capturing ongoing events, discussions, considerations, and so on in a design process. So basically what we wanted to build was a system for ourselves, and mainly in the beginning our students and potentially also other design researchers, to document entire design processes. And it was built around the general idea that in addition to describing the facts, that we would also invite the users of the system to add their reflections on an ongoing basis, so we could get a better sense of why they were building something. It was based around a simple structure that there would be events, and we could map out some characteristics of each event, and an event might have sub-events, and in addition to that, people could add notes. So let's just move to this. So in the case that you have a very simple event, you might have timestamp, some information, a description about it, and some conclusions of what was the outcome of this process, maybe attach some files, and then people could add reflections on what this meant at a given point in time. So this is a simple event, basically a phone call between two people involved in a project. They reach some kind of decision about, for instance, in this case, putting some LED lights on stairs. But you also have more complex events, for instance, in the case of a workshop, where you would have a lot of content, and actually you would have sub-events within each of these things. So in this case, actually a lot of data captured about these different kinds of events. You would be able to see the timeline of an entire project, to zoom in and out of this, and to access each of these events. And basically what this offered for us was a way to capture some of that data that would need to go into an overview map, and also to provide ourselves, our students, and other researchers with a way of doing this in a structured manner. So we've been using that in a number of projects. There is a paper, I'll give you the reference so you could read about some of our findings. And in addition to understanding each project in itself, it also means that we get a better way of comparing across projects. So for instance, a couple of our PhD students recently did a sentiment analysis across, I think 2 years of design students, the totality of their projects to figure out, for instance, how sentiments towards being in a project changed over the course of time. When would people become frustrated? And that when you can identify that, then you can dive into each individual case and figure out why, for instance, frustration is at a high at a certain point in the design process, and when people feel really happy about where a project is going. Just a few of the findings, I would say that for us it very much supported this shared reflection and discussion towards the way. It helped us better refine research questions, and it also, as I said, allows you to do studies across projects. But what we also found, and this actually goes for the other projects as well, is that documentation is very time consuming. You need to develop strategies to cope if you are to document the work yourself. And finding out what to document is in itself really problematic. You cannot capture everything, but you do not necessarily know at the beginning of a design project what it is that you need to look into towards the end of the project. You don't know where a project will end up, so how do you know what to document and what to capture? And as we introduce this tool to creatives, to architects, to designers and so on, we also quickly discovered that they had no intention of using this tool to document their own work. Documenting their work just felt like an extra workload. I'll get more into this, but it is a bit like commenting on code or something of that nature, right? It doesn't necessarily feel like an integrated part of the work. So ideally, a good documentation tool should become a natural part of the work process and provide continuous benefits to the user. And I think one of the good analogies for this is to look at notebooks or sketchbooks. A notebook doesn't feel necessarily like doing documentation. It's something that helps you along in the process, and then after you're done, it becomes documentation of what has happened. So ideally, if you want to develop ways of documenting creative work, then this could be a model to strive for. And that leads me to the second part of the talk, which is to mention a couple of projects that we're working on when creatives document their own work. We know that creative practitioners often draw upon their own repertoire of prior projects and inspiring examples. So we're interested in figuring out how we can support them both in capturing what goes on in their current projects and managing it, but also how we can better expose them to perhaps what happened in the past so that what they have done or what their collaborators have done can help them in what they're doing now. I'll mention 3 examples of that. The first one is a system. It's called Cards and Boards. It is basically a multi-device collaborative whiteboard for designers. It was based on observations and collaborations with an international design firm, observing the way that they work, the digital and physical materials that they use in their creative work process. And like so many other designers you will see, they used a lot of sticky notes, and they had this as an integrated part of their work practice to use a lot of these large-scale boards. Some of them were just blank boards, some would have templates for particular things they were doing, like SWOT analyses or service journey mapping and so on. And on this basis, we developed a system that employs built upon the underlying technology of Webstrates that Clemens will introduce in a bit, but basically a form of infinite canvas whiteboard that is online, that is collaborative, that can be used on any device that has a browser. We developed it in partnership with this design agency, and we're now trying it out in a number of use cases to see how well it does. We've carried out a series of initial studies to see how well it supports the design process. And some of the findings thus far is that it provides a digital environment that users have quickly become accustomed to. Actually, within the space of one workshop, they become accustomed to it. There are a number of the things that they would normally do using physical materials, such as sorting, rearranging, editing sticky notes, and so on, that seem to be easier than with physical counterparts. That one of the main benefits of using this type of system is that these digital spaces, in which content is persistent, accessible, and customizable, allows people to continue working throughout a project in the same space. What we often see in many other cases is that you continuously have to kind of translate between physical media and digital media, back and forth, back and forth, back and forth. They expressed it in a way that you're probably familiar with yourselves. They said that when we do these workshops with sticky notes, physical sticky notes and on the boards and so on. It works extremely well during the workshop. Then at the end of the workshop, what happens is typically that you take a photo of the board with the sticky notes on, and then it rots on some shared drive somewhere. People never use it again. So basically, it works really well when you're in the situation, but afterwards, you really need to translate it into something else to be able to continue working. This system seems to help overcome that problem. There are, of course, some issues. You need particular type of digital tools to make it work really well. It does have a steeper learning curve than analog materials. Anybody can use sticky notes and a board, but this seems to require a bit more. So for instance, if you're doing participatory design sessions, even this slight learning curve might put people off. Yeah. Moving on to the next example. Another project that is ongoing has to do with creating crowdsourced documentations of activities in libraries. We've been working with libraries now for the past 15 years or so, and it's a really interesting type of public institution to work with because there is a huge shift, a huge transition going on. As digitalization has also affected libraries, what you see is basically that their old business model has crumbled. There used to be a place for storing physical media that you could only access if you came to the library, borrowed the books, and you could have them for a certain period of time, and they were stored in physical media. And basically the promise of digitalization, of course, is that you can get access to anything, anytime, anywhere, on any device. So what is the business model of the library? Well, libraries, among other things, at least in Europe, are transitioning to becoming something else, a type of community centers where you still have all the media, the access to the knowledge stored in books and so on, but then moving more towards becoming what we call community building third places, shared public institutions, a third place between the home and the workplace. But one of the interesting things is that current digital services don't really seem to support this transition towards becoming third places. Most of the digital systems they build mainly support the same thing that you could get with most commercial services like the ones from Amazon, which is basically just access to digital media. But all of these activities that are now becoming part of the library space, debates, talks, a lot of activities and events are not really supported in that domain. So what we are developing in this project are collaborative ways of enabling people to document activities that they take part in the library space, of storing that and adding it to the library collection so that the library collection also becomes a representation of all the knowledge that is generated through people's activities in the library space. I think I can just very briefly, let's see if it's running. No, it's not running, so I can't show you a demo of this. But I would just say that this is a way of exploring crowdsourced documentation among a much wider range of users. The very last example I'll quickly introduce is that we're also doing a number of studies into how designers particularly actually manage their ideas and the types of idea archives that they use. This work has also actually, some of it been carried out in collaboration with the Design Lab here, led by Nana Ini, a PhD student of ours in Aarhus, where basically she has carried out a lot of studies and interviews trying to document the types of idea archives that designers use to capture and document their ideas, to categorize the types of content in these, and to identify the strengths and weaknesses of the current use of idea archives. And I'll end by just quickly mentioning a few of these things, that basically it seems that almost every single designer or creative practitioner has built his or her own system for doing this. They have to couple together, to piece together different existing systems because none of them are really happy with the systems that are out there. They develop their own ways of archiving over the course of time. and they find current tools very rigid in terms of how to capture their ideas. They're typically very inflexible, offering maybe only one way of representing an idea, and many of them actually seem to focus on the end product of the idea rather than the process of getting there, which is, much of the work that is carried out in creative work. So if we look across these different ways that we've explored how to document creative work, well, we find that there's definitely great potential in supporting documentation of creative work. We had that idea, of course, when we went into that, and that has just been strengthened from doing all of this work. But when people think of what they do as documentation, they simply stop doing the work. It must provide some kind of benefit and momentum in the creative process if it is to be viable and sustainable over the course of time. I've mentioned the example of a sketchbook. It doesn't feel like documentation, yet it becomes documentation. We can gather some of the required data automatically via logging and so on, and it seems that we would probably be able to capture more and more things automatically. But I think it's also vital for practitioners to take it seriously as part of their practice if it is to be viable over the course of time, just as the way of commenting code is now an integrated part, hopefully, of most programmers' practice. We also see that current tools are inadequate, and creative professionals have to piece together idiosyncratic solutions. Most of these tools are designed for individual use, not for collaboration, even though much creative work is collaborative in practice. And this indicates to me that perhaps there's a form of software that ought to exist, but that we haven't invented yet. So that leads me to introduce Clemens. We'll actually kind of pick up on this. What if software were different?
All right. I don't need that. I need this one. Let's see if I can... Give me a second while I connect to Peter's phone again. There we go. All right. So I'll change gears a bit, but my goal with this talk is to try to fuel your imagination a bit and get you to think with me about the question that drives my research. What if software were different? I come as a representative of a larger research effort, and a lot of people have been involved in what I'm going to present to you today. And let me just put them up there. I won't name them all, just give a special mention to my colleagues at the Université Paris-Sud and Telecom Paris-Tech, and also to my programmer Christian, who has realized a lot of the stuff. He sits down here somewhere. There he is. And the latter part of this talk is work that my former postdoc, Roman Redl, has been doing and done most of the implementation work of. And I have a bunch of slides that I've cold-heartedly stolen from Roman's presentation at WIST a year ago. Anyways, the software that we use today is quite different from what the pioneers imagined when the computer revolution started to take off in the late 60s and early 70s. And calling what we have now software is a bit ironic, because modern software is not very soft at all. We use purpose-built applications and apps with little room for appropriating them beyond what the designers intended them for. And very, very few of us actually do any programming or reprogramming of our software at all. Over the summer, my PhD student met us now, and he ran a survey with around 1,100 Danish knowledge workers to uncover some of their software habits. We are still analyzing the data, so I won't go into details, but I'll just show you two charts that I find interesting. One question we asked was, how often do you read? To you, I don't think it's surprising that more than 80% of the respondents either never or almost never reprogram the software. Actually, I think you might even be surprised that so many people responded that they do. Now it should be said that around 10% of the respondents were professional programmers in some capacity, and then add to that a bunch of bogus responses and misinterpretations of the question. A few more actually changed their software using extensions, but the majority never or almost never changed their software. They just use it as it comes. We also asked them to enumerate the applications they used, and it was, again, unsurprisingly, a list of general purpose applications developed for a mass market. The year before, MIDAC interviewed a bunch of knowledge workers in non-standard employments about their experiences and relationships to software. And with non-standard, I mean workers who don't have a fixed contract, but work, for instance, as freelance copywriters or journalists. And one finding from the paper I found extremely important is that they attached a lot of their value to their skills with particular tools. And when they had to collaborate with others on the same on shared digital documents, they had to compromise on these skills and compromise on their values. They had to pick the lowest common software denominator, as MIDAC dubbed it. Take, for instance, this quote here. The thing with Keynote or Google Slide or something is that it's so easy to use, but if you really want to do it beautifully, I would never use that program. I would love to do that presentation in InDesign, but since only 10% of people involved in the project know how to use it, we made the compromise of working in Keynote. But they happen all the time, those compromises. So if you choose a different application silo as your collaborator, you're in trouble. Then you have to compromise on your skills and resort to a to you inferior tool. And if you want to collaborate in real time, you typically have to resort to even worse tools. When they make a change, it's like, whoa, it's like I'm starting all over again. It's huge, and it's like, what am I doing here? So even if sticking to one application, its life cycle is more or less out of your hands, and updates to the software that with web-based applications like Google Docs can happen overnight, may compromise the skills that you've built up or render old documents and materials useless or broken. Software today is synonymous with applications, and we take that for granted to the degree that we have difficulties even imagining an alternative. We use one-size-fits-all applications. Applications are difficult to adapt, so we have to adapt. They're incompatible with each other, so we have to compromise when collaborating with people who've made other choices in tools than ourselves. Applications are also rooted in a tradition that strongly separates creating and using software. There's developers and there's users. Users, as we see, don't change their software, they just conform. Now, is this a question of computing literacy, that we don't reprogram our software? Well, perhaps partly, but even a massive effort, for instance, in teaching computational thinking won't solve the fact that our everyday software won't allow us to apply what's learned, so it will stay with the thinking. But what if software were different? Now, almost 50 years ago, Alan Kay famously imagined future computers taking the form of these paper pad-sized devices he called Dynabooks. And according to Kay, interaction would happen through personal dynamic media that would let us mold and channel the power of the computer to our own needs. And I think it was in the late 60s, Alan Kay drew this picture. He had this vision of two kids, Jimmy and Beth, that were sitting in the grass playing Space War across their linked Dynabooks. They found the game a bit too easy, so they started to collaboratively tinker with the program code to change the gravity on the ship to make the game more challenging. So in Kay's vision, software was an expressive creative medium that could be tinkered with and appropriated for personal and idiosyncratic needs and desires. And one thing that struck me also with Kay's vision was that there weren't, as such, the modern distinction between applications and documents, as we know so well from software today. In our work, we've tried to go back to this idea of software as a dynamic or computational medium, but explored what that would mean in our modern world of computing. And in the following, I'm going to present you with some of the experiments we've been doing with that. Now, what would we have if we didn't have applications and documents as we know it? What could we have instead? We've been using a concept coined by my colleague Michel Baudin-Lafont in Paris called information substrates, or just substrates for short. And substrates, as we think of them, are software artifacts that embody content, computation, and interaction. They can act as what you traditionally call an application in one use situation and a document or a domain object in another, which I'll try to show you in a moment. If you think of it, web pages are actually kind of information substrates already. Web pages, they represent content that mixes text, images, interactivity, video, etc. And they do that in a platform-independent way. They are globally addressable by their URLs or their address. And content on the web is represented in both an easy-to-store and easy-to-share text format, HTML, and has this standardized runtime representation. So it has a standardized representation in the browser that can be manipulated at runtime to do dynamic stuff using JavaScript, or it can be inspected and edited directly through the browser using the developer tools that's built into all browsers. But in traditional web, this document is ephemeral, this DOM is ephemeral, and local changes to it, they do not persist, and they're not sent to other clients. Even though you might want to go in and change the front page of CNN.com, then if you do it, it's only you who see it, and it's not stored anywhere or shared with anyone. But what you see here is a web substrate, or a Webstrate for short. And a Webstrate is a web page where changes to the document object model, or the DOM of the page, persists and is synchronized to all clients of the same page. And in the remainder of this talk, I will explore how that makes software different. So here I'm using two computers, one showing the slideshow on the projector, what you see, and my own over here for controlling the slideshow. And I can edit the slides from here. So it says Webstrate instead. The slide actually also contains some JavaScript. If I hover here, you can see there's some code. You don't have to understand or read and understand the code. But what it does is that if I click here, this heading starts rotating, and I clicked on this computer over here. Now I'll try to catch it on the other computer. There we go, to stop it. And finally also I can edit the page directly through the developer tools here, so I could in principle inspect this here and say this is really a Webstrate. And now there's too many cables here, so I won't lift the computer up, but it's synchronized to the other computer. You have to trust me. The principles of Webstrates is extremely simple. When a browser opens a specific page on the Webstrate server, say my Webstrate, then the Webstrate JavaScript client is loaded into the browser. It gets some data about this particular page from the Webstrate server, populates the document, and then it starts observing changes to the document in the browser, but also changes from other users that have the same page open. And that includes changes to the style sheet that defines how the page is rendered on the screen, and also to the code that's embedded into the page. What you see here is also a Webstrate. And this is the paper we wrote about Webstrates for WIST, loaded in what you see is what you get style editor Webstrate. And it is actually, it's not just the PDF, it's editable. And to eat our own dog food, we collaboratively wrote the paper using Webstrates, and the PDF in the proceedings was generated from this Webstrate. What I want to get at is that in the paper editor, we're using a trick that's possible with web technology, namely to transclude one Webstrate into another. And transclusion is an old hypertext principle that means the inclusion of part or all of an electronic document into one or more other by reference. And because we're sharing the document and all of it, nothing but the document, then transcluding a document into an editor becomes necessary to be able to edit it without having to put the tools directly into to the document. And transclusion is also the mechanism I use to control the slides. So if I click here, it actually opens my slideshow editor here. And you can see that I have my notes, and then I have the slides here embedded in the editor, where I can edit them and I can change slide, etc. So what you're looking at is a browser pointing at my slides, and what I'm looking at over here is a browser pointing to my slide editor that then transcludes the slides that you are looking at and manipulates which slide is shown, etc., etc. Now, CSS or cascading style sheets provides a nice separation between content and presentation, which means that from an editor Webstrate, I can apply new styles to a transcluded document. And you can see the mechanism here. To the right, you see an unstyled document. To the left, we have the editor that transcludes the document in an iframe, styles it according to a reference style sheet, and provides various tools for marking up the text. Here, I bolded a piece of text in the abstract. One of the things that we've then explored using this trick is what we call asymmetric collaboration, because suddenly a document can be transcluded into multiple editors, allowing collaboration on the same document with personalized editors, like here. So here the use case is that we have Bob to the right, the professor who prefers what you see is what you get style editor, while his grad student Alice to the left prefers a single column light on dark editor. And they can collaborate, so Bob can edit the abstract down here and then it synchronizes to Alice's editor. Or Alice can use this mechanism to collaborate with herself to write on her editor on the laptop while the print preview synchronizes on the iPad. Or there might be a Webstrate representing a figure that's transcluded into the document here that then can be edited in one tool on a drawing tablet for sketching it up and using bitmap editing, and then moving to a vector graphics editor on a laptop, all while everything synchronizes in the place where the figure has been transcluded into the paper. This is Alice's editor from the video from before. And this editor is not only visually different from Bob's, what you see is what you get editor, but it's also functionally different. So it has a tool for handling citations where I can go down here and, for instance, write visor, then select it and hit the cite button, and then a reference is added to the text and it's added to the list of references down here. Now, this actually uses another Webstrate as bibliography. It's transcluded in here, but hidden. But I can open it, and it's a very simple tool where I can import some references in BibTeX and get it into an HTML-like document, and that serves kind of like a database for the tool in this editor. Now, you can imagine that Bob, he would be interested in having this tool as well. But you could also imagine that Bob, he's not super technically savvy, so he asks Alice to install the tool for him. So in this case, what Alice can do is that she can export a piece of code from her editor, then open up Bob's editor on her computer, paste in the snippet of code, and then immediately the tool becomes available in Bob's editor, so he can write a keyword and hit the cite button, and a reference is added to his document. So what you just saw was collaborative runtime extension of a user interface. And that's possible because the editor is also a Webstrate, and therefore it's collaboratively malleable. And Alice can edit Bob's interface remotely while he's using it if she just has the URL to it and she has write access to it. I won't go into details about the technicalities of the implementation. I'll just mention that what we basically do is to apply the same type of algorithms as used in Google Docs, just on the whole web page, and these algorithms are called operational transformation. What I will mention, though, is what happens when we develop with Webstrates. Creating Webstrates is actually very similar to traditional web development with HTML, CSS, and JavaScript, but it's quite different from building modern web applications because it doesn't require dealing with a backend or complex logic to render content from a database to HTML. From the perspective of the developer, there's no backend. There's just this persistent material that you manipulate directly in the browser. This also means that it affords a new set of design patterns compared to traditional software development, and we see these slowly emerging as we use Webstrates. For example, this is the document architecture of the editor from before. The document is a transcluded Webstrate here with the fat border, but actually also the tools that are there are also transcluded Webstrates with the dashed border here. For instance, the citation tool is this piece here that contains a Webstrate containing the code of the tool and a Webstrate containing the bibliography. And what Alice copied from one editor to the other was the textual representation of this one. And here we are playing with the idea of implementing tools following the principles of instrumental interaction, where each tool or instrument can operate on domain objects with certain well-defined properties rather than being tied to a specific application, which is the case in current systems. So the tools are independent objects that can be moved, copied, and shared. And in Webstrates, the logic of each instrument can reside in its own Webstrate, which therefore can be shared between editors using transclusions. That also means that these instruments are applicable where they make sense. So I can use a tool here, for instance, the citation tool here. I can write doing 2000, and then over here I hit the cite button that I have in my slideshow editor, and it added the citation to the slide using the same tool as in Alice's paper editor. All right. With our initial work with Webstrates, we realized that we didn't actually really decrease the gap between development and use compared to traditional software as much as we would have liked. To create software in Webstrates, we either used the developer tools that are built in the browser, which are actually not designed for development, but rather for debugging, and they're really annoying to do any production in. Or we used another approach where we developed a Webstrate that served as a code editor, where a user can load another Webstrate using transclusion and indirectly edit the scripts or CSS of another Webstrate live. That's also kind of cool. So here, for instance, one user opens the paper editor of another user and can play with the hiding and showing of the menu bar. But there's still a gap between developing and using. It happens as two distinctly separated activities. But one thing that has become particularly popular, let me just get it to load. One thing that's become particularly popular in the data science communities are what's called computational notebooks. And computational notebooks, text, code, and graphics, they live in the same document. And you can execute code in the document, like here in Jupyter Notebook. And as you can see in the video, interactive notebook, or computational notebooks has blocks of text and code. And it allows you to do live computation within the document, for example, for statistical analysis or to generate interactive visualizations. The approach to software taken in interactive notebooks like Jupyter I find extremely interesting. And Fernando Perez, one of the co-creators of Jupyter, calls the use of these notebooks literate computing. He says that literate computing is the act of weaving a narrative directly into live computation, interleaving text with code and results to construct a complete piece that relies equally on the textual explanations in the computational components. So it treats code just as another way of expressing yourself, similar to text, images, and videos. And what we wanted was actually to be able to develop Webstrates in a literate computing fashion, where we can just mix development and use, and mix writing prose and making content with computing, with programming. With CodeStrates, that I will spend the rest of the talk talking about, and which is mainly the hard work of my former postdoc Roman, we've adopted a literate computing-inspired approach from computational notebooks and married it with the Webstrates platform. And by this, we try to push the literate computing approach by allowing for collaborative computing, but also extension and development of applications with state inside the notebook. We wanted to play with prototyping in a manner similar to programming playgrounds that you might know, like JS Fiddle and stuff like that, but with the potential for playgrounds to become usable applications by persisting their state. And then to provide this development environment for Webstrates that goes beyond the paradigmatic application document model. Like with Webstrates, CodeStrate is essentially a web page, but where the content, presentation, and behavior can be edited from within the page, and where these edits are inherently made persistent. So let me just demonstrate that for you. So CodeStrates looks like this. This is a section. I can add a paragraph here where I can write some text. Write hello world. Now I can also edit this as HTML. So I could write it's an A1, hello world. And this one also can have CSS styling. So right now it has a class writing. I'll just remove that one. But I can give it an ID, let's call it demo. Let's try to add a bit of styling to that. So let's say that demo has background color white, and the text color is black, and it has a minimum height of 200 pixels. Let me just log it for further changes. Now I want to add a bit of interactivity, but before that, let me just create a CSS class called inverted. Get rid of this cursor that follows me. So the background color when it's inverted is black, and the text color is magenta. There we go. Let's test this by giving the class inverted. Inverted. That worked. All right. So now let's try to add a bit of interactivity. So I'll add a code paragraph. I'll get a handle of the element. I'll call it demo. I'll add a event listener on a click, have a function called when I click on it, where it will take whatever was clicked on and toggle the inverted class. Make this run on page load and run it, and now we have this. All right, so now let's full screen this, and now we have a super sophisticated web application. But let's try just to open this one on a phone. There we go. And you see, it's actually a collaborative application. But what I could do out here, now it gets very tiny, but I could break out here and say, actually, I want this to be orange. And you can see this creates this nice way of actually being able to interact with applications collaboratively, but also break out and reprogram them. Basically, only the imagination sets the limits for what CodeStrates can be used for, because it's a generic programming environment. But here are some examples of what we've done with it. We've built kind of standard notebooking systems with it to analyze data, for instance, but also used it to build applications, for instance, tools for doing presentations, as I'm using here. That was handy the other year where Midas, he was denied ESTA access to go to the Chi conference, so he created his slides as a CodeStrate, was a telepresent robot, and then controlled the slides from back home. We also actively use it to teach programming, to create interactive programming assignments for our students, where we can play with all sorts of fun stuff, like changing pixels in a picture of a cow, or build games, collaborative games, or multiplayer games in CodeStrates, and play with physical computing. Actually, this game, I can just load it up on a slide here. This is a small game that we had a game developer program in a day. It's a version of a tank game he had programmed before, so he made a simplified version of it. And actually, I see that there's a bug in this one because the bullets doesn't seem to bounce, so let me just try to break out. Yeah, this line shouldn't be here. So let's get back. Yes, now they bounce. All right. So playing with the idea that you can actually have these running multiplayer games that are collaboratively reprogrammable. And actually, one thing I just want to show you is that, let's see if I can get to change the slide here. Yeah. So I'll get back to Alice in a second, because this is a tool that Alice made for herself. But if you look in the side here of CodeStrates, you can see that the whole of CodeStrates is actually self-contained. So the implementation of a CodeStrate lives inside of a CodeStrate. So I can go in and look at the code, for instance, that does all the bootstrapping of the execution of the code, and its documentation also lives inside here. Now let's get back to Alice, because Alice, she has made this tool or she's made a CodeStrate for doing reviews of papers, where she's embedded the PDF that she can annotate down here. But she also wanted to make sure that she keeps a positive tone, so she's made a simple tool she can use to do sentiment analysis of the text. So here it looks good because she's using some positive adjectives. Now, and actually it resides in here. You can see she's just hidden it. It's a very simple tool. It uses a library called Sentimood to do the sentiment analysis. Now Bob, he has adopted Alice's way of doing reviews. So this is Bob's review of a paper. But Bob has also been told that he's often a bit too aggressive in his reviews. So he wants to get a copy of Alice's tool. So he asks Alice, can I get this sentiment analysis tool so I can check my review? And then what Alice can do is say, sure, I'll just package it up. So Alice can turn this one into what we call a package by pressing this button here. Then she has to provide a bit of metadata. She has to tell what assets she's using. There's the Sentimood file. This one doesn't have any dependencies. Let's remove that. It doesn't have a GitHub repository. Let's remove that. That should be good. So now we can go to Bob's here, and we can go to package management, install and update packages, point it to Alice's review, update the list, and then didn't that work? What did I do wrong? One second. Anyways, that's the case with live demos. But then he would be able to copy over the package from Alice's CodeStraight and run the Sentimood tool on his text, and you would see that it will show a lot of angry smileys because he has a very aggressive text. And what Alice also could have done is to push these packages to a CodeStraight representing a repository of tools. That's what we do in our own research lab. We create a lot of these small packages and send it to a repository that we can copy in, and then hereby add new functionality to our notebooks. Okay. Let's go here. We also use that, and I won't talk in detail about that, but we use this mechanism to build a real-time collaborative and extensible data analytics platform on top of CodeStraits called Webstrates, where you can install different packages for doing data analysis and data visualizations that I unfortunately don't have time to talk about now. All right. So what if software were different, like how software built on Webstrates are? Well, we don't know before we try it. And you may already sit and have identified a number of challenges to mass adoption of an approach like I present with Webstrates. I know of a few myself. What's, for instance, the business model when you give everything away as soon as a Webstrate is loaded. But I'm not really driven by creating the next big thing, but by a genuine curiosity towards how things could be different. So we are trying to build a platform that allows us to explore what we call possible alternative futures. And our goal is that soon we'll be able to deploy a lot of this stuff beyond the lab to study how it would fare in the wild. Now, our work with the Webstrates has a lot of limitations, manpower being one of them, but we're also building upon technology that's beyond our control and on top of a software stack that also comes with limitations. And we're not programming language researchers, so developing a programming language that's more in tune with the kind of activities we imagine going on, for instance with CodeStraits, has simply not been possible for us yet. And I, for one, do not see kids programming in JavaScript as the future of computing. I would love to be able to create something like variant of Logo or Scratch or HyperTalk from HyperCard to integrate in CodeStraits. Our effort in this space is not the only one. Jim has been addressing a number of these challenges from various angles throughout his career. There are also radical ideas that touches upon this idea of software as a medium, a dynamic medium. For instance, the stuff presented by Brett Victor in his ambitious dynamic land vision that I encourage you to look up. But I'll just end this talk by encouraging you to consider what if software were different, and also consider that our obligations as academics in computing is to explore this and show that the status quo of software is not God-given or set in stone. CodeStraits is available for all of you to try out and tinker with. You can find it here on this URL. You're free to start using it for your own projects, and welcome to contact me if you have ideas or want to collaborate. Also, the Webstrates platform is available open source, so you can set up your own server for it. That's it. Thanks.